Good afternoon. We are going to do notes for Unit 7, which is on cubic polynomials. This is day 1, and we're going to cover graphing cubic polynomials. So the objectives today, you need to be able to graph a cubic, and number 2, you need to be able to describe transformations that are being done on cubics. So this will draw on old knowledge because we've already done transformations early in first semester. We did it with absolute value graphs and we did it with quadratics or parabolas, but we did not do it with cubics. So we're going to review that a little bit. Okay. Roman numeral 1. Oh, by the way, you need graph paper for this entry task. If you do not have graph paper, pause the video, get graph paper, and return because graphing is obviously the point of today. And to get credit for your notes, you need to actually have them graphed. You also need a ruler. Multiple colors would be a helpful thing, but not required. Okay, Roman numeral 1, the formula of a cubic. And after a while, these formulas start to look familiar. All right, here we go. F of x equals a times x minus h, quantity cubed, plus k. And of course, it's a cubic because it is cubed. Now, in this formula, there's something called an inflection point, which is actually the most important point in the graph. And the inflection point is where the slope changes. So it either goes from rising and then rising there or coming down. But it's you can think of it kind of where the slope changes to where it's flat. It's a fairly flat area. So a flat slope. It's also the exact middle of the graph, so it is important in terms of shape. All right, the base graph, the one that you start with and then do your transformations to, is f of x equals x cubed. Okay, we're going to take a moment and actually graph the base graph so that you know what it looks like and what your graphing should look like. So for these, you're going to need a slightly bigger pair of axes. These graphs tend to shoot to infinity really fast. Okay, so for the base graph, if I rewrite the base graph, f of x equals x minus 0 cubed plus 0, you can clearly see that the inflection point is 0, 0. So that's 0, 0. Now, from there, you're going to want points that are even. So a t-chart will work. And you want to be pretty close to each other. So like 1 and negative 1, 2 and negative 2. When you substitute a 1 into the equation, 1 cubed is 1. Negative 1 cubed is negative 1. So 1, 1 is here. Negative 1 is here. Now for the 2's, 2 cubed is 8. Negative 2 cubed is negative 8. So you can see how fast these shoot up. So 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8. There's 2, 8. Negative 2 to the left, 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, negative 8. There are no asymptotes. There we go. There are no asymptotes for this, but it does get steeper and steeper and steeper. It's never quite flat, but it's very difficult to draw that. So generally we draw it as well as we can until we get to the middle part. That definitely needs to be a smooth S shape, and then it keeps going. All right, that is your base graph of a cubic. You will notice that it is an odd function. And your odd function, remember that in an odd function, f of negative x is equal to the same thing as negative 1 times f of x. That's your formula for an odd function. You can also use the trick of if you turn the function upside down and it looks the same, then it's odd. So this is definitely an odd function. Now once you've done transformations to it, it may or may not still be an odd function, but the base function is definitely odd. Okay, so that's your basics on graphing. Now let's go to transformations. So Roman numeral 1, Roman numeral 2, transformations. And we are going to graph the equation f of x equals x plus 4 cubed plus 1. All right, and we're going to need some space for this. So give yourself a good-sized pair of axes. Okay, so we're going to graph this, and we're going to graph it using transformations. And that's so that we can describe what's being done to the original equation, which of course was y equals x cubed. Okay, so remember that when you do transformations, you always start on the inside of the x's, and you always do stretch, shrink, transformation, or translation, or reflection. In this case, we've got x plus 4, which is a horizontal translation, negative 4 to the left. Remember, it's always opposite. All right, so let's draw our original function. And I'm going to go down here and we're going to do the point strips down here. So here's our original, which we just did. So we have 0, 0 as your inflection point, 1, 1, negative 1, negative 1, 2, 8, negative 2, negative 8. That's our base graph. All right, so if we translate that, x plus 4 cubed, it's left translation 4, so we're going to subtract 4 from our 0. 0 minus 4 is negative 4. 1 minus 4 is negative 3. Negative 1 minus 4 is negative 5. 2 minus 4 is negative 2. Negative 2 minus 4 is negative 6. And the y's are unaffected. 0, 1, negative 1, 8, negative 8. All right, we're going to confirm that we have the right points graphically. So we're going to start by graphing the base function. I'm going to use black. 0, 0, 1, 1. I have 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's up at 8. Negative 1, and negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. As always, if I am going too fast for you for your graph, just pause the video, finish your graph, and then restart it. So there's your original function. Now, if we did this right, when I plot my next set of points, it should be shifted left. So here we go. Negative 4, 0. So 1, 2, 3, 4, 0. 1, 2, 3. Negative 3 up 1. Negative 5, negative 1. And then it's negative 2 up 8. And negative 6 down 8. So sure enough, this is looking like it's been shifted or translated 4 to the left. So that looks really good. Okay, we're going to do the next transformation on this, which is to add 1. So y equals x plus 4 cubed plus 1. This is a vertical translation, plus 1 up. And remember, on the outside, what you see is what you get. All right, let's go to our point to point. So y equals x plus 4 cubed plus 1. And in this case, we are going to add 1 to all of the y's. So the x's are going to stay the same. So -4, -3, -5, -2, and -6 are unchanged. Only the y is affected. 0 plus 1 is 1. 1 plus 1 is 2. -1 plus 1 is 0. 8 plus 1 is 9. -8 plus 1 is -7. And there's our new set of points. So let's go ahead and plot that and see if it's moving in the right direction. All right, -4, 1. 1, 2, 3, 4, 1. -3 up 2. -5 is at 0. -2 is up at 9. And -6 is down at -7. So when you move one of these graphs up, what you're going to notice is that the graph gets really close to where the original one was. That's because when you shift up and down, you've got the lines are so steep that the original and the new one pretty much just blend in with each other. So when we graph this, you kind of graph alongside it until you get to the middle part, the inflection part. And then as it gets to the end, it gets infinitely close again. And that's fully to be expected. And yes, this looks like it has been translated 1 up, so we must be correct in our translation. All right, last thing I want to do, here's our points again if you need those. Last thing I want to do is do a couple of reflections because we haven't done those a ton, so I want to review with you how to do that. Okay, so this is example 2. We're going to do y equals -x cubed, and we're going to do y equals -x quantity cubed, and we're going to compare those two. All right, so let's draw our graph. Got a little bleed through from my other work. Okay, so our base graph, let's put the points over here. Our base graph has an inflection point at 0, 0, 1, 1, -1, -1, 2, 8, -2, -8. And yes, you will have those memorized by the end of your homework. So 0, 0, 1, 1, -1, -1, 2, 1, 2, 3, 4, 5, 6, 7, 8, up 8, -2, 1, 2, 3, 4, 5, 6, 7, 8. Here is our base graph. Don't forget the arrowheads. Graph's bigger than a Post-it. All right, so we're going to do y equals -x cubed. We're going to do the first one. So let's do this point by point, and then we'll do it graphically. So point by point, I'm going to use the same x values as what I have here. If x is 0, -0 is just 0. If x is 1, 1 cubed is 1, but then it's multiplied by a negative, so it's a -1. If x is -1, -1 cubed is -1 times a negative is +1. +2, 2 cubed is 8 times a negative is a -8. And the last one, -2 cubed is -8 times a negative is a +8. All right, those are our new points. Now, to describe what this is, with the negative outside of the equation, not with the x, this is a reflection across the x-axis. I always think of it as if it's outside, the y's are changing. They're flipping from top to bottom and bottom to top, so obviously they're going across the x-axis. All right, let's plot our points and see if it agrees with that. 0, 0, 1, -1, -1, up 1, 2 down to -8, -2 up to +8. And yeah, that looks like it's been flipped across the x-axis. That's our line of reflection, so that looks good. All right, last one. If the negative is in with the x, then it is a reflection across the y-axis. The x's are changing. So this is your y-axis. So it's going to reflect across this line. Okay, so let's do those points. I'm going to do them over here in blue. And again, I'm going to use the same x's as the base graph and do the transformation. So if x is 0, negative 0 is 0, cubed is 0. If x is 1, it's being multiplied by a negative 1, and negative 1 cubed is negative 1. Now negative 1. Negative 1 times a negative is positive 1, cubed is 1. Now positive 2. 2 times a negative is negative 2. Negative 2 cubed is negative 8. And the last one, negative 2 times a negative is positive 2. Cubed is positive 8. So there we have our points. And let's go ahead and plot those. So 0, 0, that never changes. 1, negative 1, we're right there. 2, negative 8 is here. Negative 1, 1 is here. And negative 2, 8 is here. So, in fact, our reflection across the y-axis ends up being exactly the same graph. Which makes sense because it's symmetrical this way and it's symmetrical that way. Okay, that is all that I have for you today. It's a review of transformations. You will need graph paper. There is a worksheet, and then there are some problems out of the book as well. So look at your homework notes and test schedule and be sure that you know what you're supposed to work on. Have a good afternoon.